Hello, welcome back to another lesson. In this lesson, we'll be considering the OWASP Top 10, which is something every serious developer, security engineer, and architect must understand. The OWASP Top 10 is not theory. It is a reflection of how real systems get broken in the real world. Let's get right into it. Why every developer must know this? They need to know this because the OWASP Top 10 is an industry-recognized security benchmark. It highlights the weaknesses attackers exploit most often, and it is based on real-world breach and attack. Also, security teams across the world use it as a reference point. So if you build web applications, this list applies to you, and if you ignore the list, you are building blind. Let's now consider what OWASP is. What is OWASP? OWASP stands for Open Web Application Security Project. It is a global non-profit organization, and its mission is to improve software security worldwide. It also provides free tools, documentation, and guidance. Also, it is community-driven and widely respected. Let's now consider what the OWASP Top 10 represents. It is not just a random list, so it is a ranked collection of the most common and impactful web risks. The ranking considers how often they occur and how damaging they are. So it is based on prevalence and impact. It guides secure development priorities, which means that it helps teams prioritize security efforts. Also, it is updated periodically to reflect new threat patterns. Let's now consider them one after the other. Here is the first one. Broken access control. This is currently the number one risk, and what this is all about is that users are able to access data they should not see normally. Also, server-side authorization checks are missing or weak, privilege escalation becomes possible, and it is extremely common in modern web applications. The next one is cryptographic failures. This focuses on protecting sensitive data. For cryptographic failures, we can have weak encryption, that is, encryption might be weak or missing, keys are poorly managed, sensitive data becomes exposed, and confidentiality is directly broken. The next one is injection. Injection attacks remain very dangerous. Examples are SQL injection, and another one is command injection, and for this, untrusted input is executed as code, and this happens because input validation is weak. So attackers turn user input into system commands. That is basically what happened here. And they use that to dump data from the database or gain access to the data they shouldn't gain access to. Let's consider the fourth one, which is insecure design. Sometimes the problem is not code, but the architecture. So this means that if security is not considered during design, that is insecure design. Also, if no threat modeling was performed, and if we have risky architectural decisions that were made early, that is, if poor design decisions were made early, and I must say that these issues are very difficult to fix later because it's an architecture problem. The fifth one is security misconfiguration. Misconfiguration is one of the most common causes of breaches, and that is why it is part of the OWASP Top 10. So this includes default credentials that remain unchanged, cloud storage that is left publicly accessible, unnecessary services that are enabled. Also, we have common cloud mistakes, and I must add that small configuration errors can create massive exposure. Let's consider the sixth one, which is vulnerable and outdated components. Software depends on components, libraries, and frameworks. So we can experience vulnerable and outdated components if old components remain in use, that is, components that are no longer secure or safe to use in an application. If developers or a developer is still using that, then there is a problem. We also have known vulnerabilities that are ignored. Also, we have supply chain risks. And lastly, we can experience dependency management failure, which means that poor dependency management can create attack paths. Let's consider the seventh one, which is identification and authentication failures. Identity weaknesses lead to account compromise, and we experience this when password policies are weak, when multi-factor authentication is missing, when session handling is broken, and all of these lead to account takeover becoming easy. Next, we have software and data integrity failures. Integrity is one of the core principles of cybersecurity, hence it must be protected. So for software and data integrity failures, it happens because Software updates are not verified. So that means when we have untrusted software updates, or when CI/CD pipelines are compromised, or when supply chain attacks inject malicious code, and this will lead to broken trust in the system. So we can say that it will lead to integrity violations. Next, we have security logging and monitoring failures. There is one thing in cybersecurity: if you cannot see it, you cannot stop it. For you to stop it, you have to see it first. And this is why security logging and monitoring is very important. So when we experience security logging and monitoring failures, that means that there is no logging, there is no alerting, breaches go undetected for long periods. That is, we're going to have slow breach detection, and this help attackers to remain inside systems unnoticed. Let's now consider the 10th one, which is the server-side request forgery, which is known to be SSRF. We are going to learn more about this in the next lesson. SSRF tricks the server itself. For SSRF, the server is manipulated into making internal requests. Attackers then access internal systems, and cloud metadata services can be exploited. And for SSRF, detection is often difficult. Sometimes it can be very, very difficult to detect this. Why is OWASP Top 10 a security baseline? We should ask ourselves this. Well, I would say that the list is a foundation, not an option. So it is a security baseline because it guides secure coding practices, it helps prioritize testing and reviews, it is used during audits and assessments, and every developer should understand it deeply because it is the foundation of web security knowledge. Let's take a test together. Here is the question. Which OWASP category involves executing untrusted input as code? Here are the options. Pause your video, read through the options, pick your answer and drop in the comments, then come back to play the video. So what's the correct answer? The correct answer is B, which is injection. That's all for this lesson. If you're here to subscribe to our channel, please do that now. Also, do not forget to like, share, and comment. Thank you so much and see you in the next lesson.